One important aspect of Octave is the ability to create some nice and good looking plots. There are multiple plot commands available in Octave, but the most important one is just plot. Let's say we want to plot the sine and cosine function over one wavelength, that is over the interval from 0 to 2 pi. To do so, we specify the range over which we want to plot with the command x is equal to linspace 0 to 2 pi, and we plot 100 points. Then we say y is equal to sine of x, which, as I explained before, operates on each element. Now I just write plot x and y, and it will open a window with the sine function, which we might have seen before. So this is it. We can plot something with just 3 commands. If I change the linspace in such a way that it does not has 100 points, but just, let's say, 10, and plot everything again, then we will see that the plot will become very inaccurate, because I do not have 100 points anymore, but just 10. So this does not look like a smooth sine function anymore. This is just a very ugly and inaccurate polygon, because I have not enough points. A good number of points would be something between 100 and 1000. If I close Octave now and open it again and want to execute the plot command again, I will see that I get an error message because x is undefined. Of course, I have to redefine x again and then define y, and then use the plot command, and only then the plot will work. So this is a bit inconvenient. So what I would do now is that I write a script file where everything is saved. So let's call the script file example plot.m, and then here I write everything as before. I clear the screen with clear screen. Then I close the feature, and x is in space 0 to 2 pi 100 points. Suppress the output with a semicolon, and y, just use y, maybe just at once. X is equal to plot x sine of x, and yeah, this is it. If I save this plot and execute it with by calling the name of the file, which is example plot, but without .m, it will open our plot. So this looks a bit plain and boring. There are no annotations, but this XKCD comic says that it is very important to label the axis. So how do we label the axis? It is simple. We just use the command xlabel. So I want to give it a title and axis labels, and I can do that with the command xlabel, and just, what should I call it? X-axis would be some reasonable name. Y-label, I will call it y-axis, and I want to also give it a title. I will give it the title trigonometric functions. Now if I save the script and reload it again, I see that here is written x-axis at the bottom, y-axis to the left, and the title trigonometric function to the top. But instead of just plotting one function, I want to plot multiple ones, so also the cosine function, for example. One might expect that we can do this by copying this and changing the sine to cosine, but if we save the script file and re-execute the code, we just have a plot of the cosine function here. This is the plot of the cosine function, and the plot of the sine function got removed, which is inconvenient. I want to have both in one plot. To have both in one figure, I have to use the command hold on, because otherwise anytime I execute the plot command, the previous plot will get lost. So if I re-execute the script again, now it will plot both into one. So this looks a bit weird. I want to have different colors, not this blue and orange, but something different. I can change the style of the line with the argument r minus. What this does now is draw a normal line. Minus means normal line and r means red. I can do the same for the plot of the cosine function, but this should be a blue line and it should not be a normal line but a dotted line, so I make dots. Other options which are available would be Y for yellow, K for black, G for green, and so on. So if I plot this, now we see the sine function is in the nice red line and the cosine function is in blue and it's in a dotted line. So as I mentioned, it is very important to have annotations and labels, but except for the labels of the axis, we do not have labels of the plot. We do not have a legend, we want to have a legend. This could be very simply done with the command legend. Now we have a legend. Now it's written there, data 1 and data 2. This is a bit inconvenient because was that supposed to be data 1 and data 2? So let's give it a name like sine and cosine function. We can do this by writing legend and then provide the names of the functions which we plot inside some curly braces. So this would be the sine function and then comma, the next element would be cosine function. And now if I close the curly braces and then the legend, save and re-execute this plot, it will give me a nicer legend with a sine and cosine function as a label. But this is not how we would do this. This is inconvenient because what happens if I change the order of my plot? Let's say I plot the cosine function before the sine function. If I change the code because I do some debugging or want to try something out. Now if I save and redraw the plot, we will see that the legend becomes incorrect because the first plot is not the sine function anymore, it is the cosine, so it is incorrect. What I could do now is change the legend such that this cosine is at the first and sine function at the end. But this is very, very inconvenient because anytime I have to change the order of the plots, for example first cosine and then sine, I also have to change the order in the legend, which is very inconvenient and which can lead to errors and mistakes. So this is not how we would do this. Instead we just write legend and provide the names of the plot as a parameter. To do so we write display name and then the name like which we would have written to the legend before, like cosine function, and at the bottom the same, display name sine function. Now if I save this and re-execute this, I will see that the plot is correct and the legend is also correct. And if I change the order of my plots again, I will see that the order in the legend changed as well, but, and this is important, the legend is still correct because the sine function is connected to the red line and the red line is the same function, so everything works as expected. Okay, so there are some other ways how we could make this plot a bit prettier. Let's say I want to change the location of the x axis. The x-axis here is currently at the bottom. We see that it goes through the point -1, but I don't want it to go through the point -1. Normally it would go through the origin. So what we want is move the axis to the origin. To do so, we use the command axx equal to gca, which means get current axis. So the axis will be saved in the variable ax, and then I can set the property of this ax, and I want to set the property x-axis location to the origin. If I save this, I will see that now it will draw the x-axis to the center such that it goes to the origin, so to the point 0, 0. Can do the same for the y-axis, but there is no change here at this moment because this is how it do this already. Now it draws a box around my plot. This here has nothing to do with the axis, it's just a box. I don't want to have this box, it looks a bit weird, so I can just write box off. And I want to have a grid in the background, which I can do with the command grid on. So if I write grid on, I have a grid in the background and the box, as you see, got deactivated. Now that I have a grid in the background, we will see that depending on how I resize the window, the aspect ratio of the plot changes. Yeah, one unit on the x-axis is not equal to 1 unit on the y-axis, which is very inconvenient. It looks weird. To achieve this, I can use the following command: d-aspect 1, 1, 1. So if I write this and re-execute my code again, I will see that now it's exactly how it's supposed to be. 1 unit on the y-axis is equal size as 1 unit as a y-axis, so that's how we want it. Okay. One thing which I also want to change is the x-ticks and x-ticks labels. As we see here, we have the x-ticks 1, 2, 3, 4, 5 and 6. This is not what I want. I want to have the x-ticks at the location 0, pi, 2 pi and maybe 3.5 pi, not at these integer numbers. So I can specify the x-ticks with the command x-ticks. And I give it an array at each position where I want to have an x-tick. So 0, pi half, pi, 3 over 2 times pi, and 2 times pi. So now if I save this and redraw the plot, I will see that it does exactly what I said. 3.14159 is pi, 6.28319 is 2 times pi. So the x-ticks are at the specified location, but the labels are not how I want them. I want to have here not normal numbers, but the labels pi and 2 pi. To do so, I write x-tick labels, and then I give an array of strings or an array of text, so I have to use curly braces. So the first label would be 0, or I could just write 0 just for fun. Then pi half, then pi, 3 over 2 pi and 2 pi. Close the curly braces, save and execute the plot, and now I see that I have written here 0 is the first x-tick label, pi half, pi, here is 2 pi, so this is now perfect how I want it. The last step would be to save this plot into a PNG file, because maybe I made a scientific computation and I want to publish this into a research journal or something like that, and this only works if I save the plot into a file. So how do I save the plot as a PNG file? This is possible with the command print. So I just write print and then give the name of the file as an argument. So let's say important plot.png, and now this should work already, but it will look a bit weird because I did not specify the file size. I can set the size in pixels with the command -s, s like size, and then x 1920 and 1080 pixels, because this is exact HD definition resolution. I save this, I re-execute my plot, and now I plotted everything, and also in the background it will have saved this in a file, which I can look with as we see now the fonts will be a bit larger, everything will look nice. So basically this is how you would plot a simple function with an Octave.